People are killing themselves over the fact that they're miserable. U.S. suicide rates are up 30% in the last 20 years, and only half of these were known to actually have a mental health problem. Okay, so you always hear about all these problems we have on TV. The fact of the matter is, the suicide rate is enormous in people who didn't even know they had a problem. So the point is, it's not going well anywhere in the Western world. So I think I've shown you our metabolic health is going down the tubes, our mental health is going down the tubes, and our money is going down the tubes to boot. Okay, and the question is this coincidence or is this being driven?
Welcome to the Mind Health 360 show. I'm Kirkland Newman, and if you, your loved ones, or clients suffer from mental health issues such as depression, anxiety, insomnia, poor memory, poor attention, mood swings, exhaustion, etc., I interview the leading integrative mental health practitioners from around the world to help you understand the root causes of these symptoms, many of which may surprise you and suggest solutions to help you heal. If you like this interview, please do subscribe and forward to others who might find it helpful. If you want further information, please go to www.mindhealth360.com or find us on social media. Now, one of the giants in this field is Dr. Robert Lustig, a scientist, academic, and clinician with many years of experience who works tirelessly to change the social, cultural, and environmental factors that impact our health. He's Emeritus Professor of Pediatrics in the Division of Endocrinology and a member of the Institute for Health Policy Studies at UCSF. He's a neuroendocrinologist with expertise in metabolism, obesity, and nutrition. He's one of the leaders of the current anti-sugar movement that is changing the food industry, and he has dedicated his retirement from clinical medicine to help fix the food supply any way he can to reduce human suffering and to salvage the environment. Dr. Lustig graduated from MIT and received his MD from Cornell University Medical College. He also received his master's in law at University of California, Hastings College of the Law. He's the author of the popular books Fat Chance, The Hacking of the American Mind, and Metabolical, The Lure and Lies of Processed Food, Nutrition, and Modern Medicine. He's the chief science officer of the nonprofit Eat Real. He's on the advisory boards of UC Davis Innovation Institute for Food and Health, the Center for Humane Technology, Simplex Health, Levels Health, and Readout Health. And he's the chief medical officer of Biolumin Technologies, Fugol, Perfect, and Kalin Health. Dr. Lustig, mainly for me, is one of the nicest men you will ever meet. Kind, humble, thoughtful, and always wanting to help his fellow human. And I'm honored to count him as a very good friend. But we are honored and thrilled to have you here with us and really looking forward to his talk on mental health is metabolic health for the brain. Welcome, Dr. Lustig.
Thank you, Kiki, and I'm going to kill you for that. I said make it short, but I do appreciate the introduction very much. I hope everyone had a good time yesterday, and that all of the concepts that were presented, landed appropriately. Today, we're going to tie a couple of those concepts together and try to provide a rational, shall we say, therapeutic modality for you that makes sense. So with that, I'm going to go ahead and share my screen. And what I'm going to try to do today is convince you that metabolic health and mental health are really the same thing, and that mental health is just metabolic disease of the brain. In order to do that, I'm going to have to do some biochemistry, but hopefully I'll make it relatively easy for you. Okay, so let's go ahead and go into present mode here. Right, there we go. Okay, very good. All right, so start with this paper that came out in 2001. And what it did was it counted up all the people with diabetes walking the face of the earth. And at that time, there were 151 million. And what was projected for a decade later, 2010, was that would go up to 221 million, a 46% increase, or as the actuaries do it, an annualized inflation rate of 3.88%. This is not what we saw. What we actually saw was there were 285 million. That's an inflation rate of 6.55%, a doubling over what was anticipated. By 2014, we were up to 422 million. And this is in the face of the recognition of the obesity epidemic and, the cutting of fat and gym memberships and, media coverage, et cetera, et cetera. That went up to an annualized inflation rate of 10.3%, a tripling over what was anticipated. By 2019, up to 463 million. By 2021, 538 million. 2030 is now estimated at 568 million. And for 2050, we are now going to be, modeling says we will be at 785 million. In other words, nothing has stopped this inexorable march. WTF. Okay. Clearly, whatever it is, we haven't touched it. And in some cases, we've made it worse. And that's the point of today. So if you take a look at the money, all right, so here we have hospital costs in red, physician costs in green, pharma costs in purple. They do not add up to the total cost because the rest of it is going to the care and treatment of chronic metabolic disease like diabetes, but not just diabetes, dementia too. And the reason, of course, is everybody wants the pill. Nobody wants the obvious. Well, maybe not the pill, maybe they want the shot, all right? The question is Ozempic a good idea? And I will just give you 3 reasons right now why it's not such a good idea. Number 1, you lose just as much muscle as you do fat. Ask anybody any little old lady, if she wishes she had a little extra muscle before she breaks her hip. Number 2, the side effects of gastroparesis. That's the reason it works, is because it actually delays gastric emptying. So that's the reason why you've got starvation as the primary driver. That's not so good, and it's actually causing major problems. There's now a warning label on Ozempic for gastroparesis. And lastly, if everyone in America who qualified for Ozempic actually got it, that would be $2.1 trillion added on to the healthcare system, which is currently $4.1 trillion, be a greater than 50% increase. And Medicare is going broke in the year 2026. How are you going to do that? Conversely, and I will make this argument later, if we just got added sugar down to USDA guidelines of 12 teaspoons per day max, we could get a 29% weight loss instead of a 16% weight loss, and we would save $3.0 trillion, a $5.1 trillion swing. Okay, but again, nobody wants the lifestyle. They only want the pill. All right, that's systemic health. Now let's do behavioral health. So what do you see here are the death rates per 100,000 for all these OECD countries, but you also see U.S. Hispanics following the same curve going down. But take a look at U.S. whites, okay, here in red. What's going on with the U.S. whites? Why do they have an increasing death rate? And what are they dying of? It turns out they're dying of poisonings, lung cancer, suicides, chronic liver disease, diabetes. In other words, they're dying of the diseases of despair. These are the deaths of despair. And Angus Deaton and his wife Ann Case wrote about won the Nobel Prize, writing about the fact that people are killing themselves over the fact that they're miserable. U.S. suicide rates are up 30% in the last 20 years, and only half of these were known to actually have a mental health problem. Okay, so you always hear about all these problems we have on TV. The fact of the matter is the suicide rate is enormous in people who didn't even know they had a problem. Here are the statistics for opioids. Here are the statistics for cocaine going up. Here are the statistics for benzos going up. More people are dying, and it's more non-college people than college grads. So very clearly, there is a economic disconnect between these two. Now, if you think this is just a U.S. problem, well, it's mostly a U.S. problem, as you can see here. 150% increase in deaths of despair over the last decade in the U.S., but here's the UK right here in red, and you're at 60%. The point is, it's not going well anywhere in the Western world. So I think I've shown you our metabolic health is going down the tubes. our mental health is going down the tubes, and our money is going down the tubes to boot. Okay. And the question is this coincidence or is this being driven? So this is where the question of what is the role of food in metabolic health and mental health and ultimately in healthcare dollars. So Gary Taubes wrote about this very nicely in his book, The Case for Keto. And as you know, the ketogenic diet is now being applied to multiple mental health and metabolic health conditions. And the question, of course, is why would this work? You know, what's special about a ketogenic diet? Well, we've known for a long time that the ketogenic diet has effects on both the body and the brain. It clearly improves epilepsy. You know, the original story is that patients in diabetic ketoacidosis back in the 1920s stopped their seizures. And that's what, you know, led Johns Hopkins to investigate the ketogenic diet as a treatment for epilepsy. Well, as you know, Christopher Palmer, writing this book, Brain Energy, for those of you who can see me on my little chiclet, I'm holding up Christopher's book, and I highly recommend it. If you haven't read this, you are remiss. This is an important volume in this field, and anybody who goes to IMMH basically has to commit it to memory. He showed that the ketogenic diet works for bipolar disorder and schizophrenia, and it's starting to look like it works in OCD and many other behavioral and mental health issues. So the question is, why would the ketogenic diet work on all of these things when medicines don't really work very well at all? The answer is because, you know, all of the things that the medicines do, the ketogenic diet does, and actually does a little bit better. It changes mitochondrial function, increases ATP generation, and almost all of these diseases are actually defects in ATP synthesis within the neuron. And it'll also change neurotransmitters, and I'll show you that in great detail in just a minute. It will increase GABA, decrease glutamate, basically putting the brain to rest. It's why it will work for seizures. It's also why it will work for depression, because you're actually increasing GABA. So, is there a role for the ketogenic diet in psychiatry? And the answer is, well, yeah, there is. We have to figure out which patients in what venue, and and how to best administer it and how to best monitor it. But Chris Palmer is going whole hog on scaling up ketogenic diet, metabolic psychiatry as a thing, you know, around the world. The question is, why does it work in mental health issues? Is it the improvement in insulin sensitivity? Because insulin causes problems with energy utilization at the level of the neuron. So when you lower insulin at the level of the neuron, then the mitochondria actually work better because you're not foisting energy in the opposite direction. You're letting it go through the mitochondria. And also beta-hydroxybutyrate is a signaling molecule. It increases sirtuins, which ultimately increase mitochondrial biogenesis. So there are some very clear reasons why the ketogenic diet might be valuable. Or is the reason the reduction in sugar consumption, very specifically the molecule fructose? Because fructose, as it turns out, is a direct mitochondrial toxin. And I will show you that directly with data. And certain bacteria in the gut grow better with sugar. And as you've learned already, the gut-brain connection is a big deal in this story. And anything that can basically put those bad bacteria at bay will have CNS improvement in terms of outcomes. So which is it? Is it the carb reduction or the sugar reduction that matters, and through what mechanism? So throughout the rest of the talk, I want you to remember, are we talking about the insulin or are we talking about the substrate? All right, so here's an example. Sugar intake from sweet food, common mental disorder, and depression from the Whitehall 2 study. So basically showing that the more sugar somebody eats, the more chances for depression and mental disorder. You know, what's the relationship there? Well, I will, show you several epidemiologic studies. Here's a one on sugary beverage intake and preclinical Alzheimer's disease, showing the more sugar consumption, the greater the risk for Alzheimer's. In addition, we have the omega-3 story. As you know, we need EPA and DHA, eicosapentaenoic acid, for neurotransmission. We need DHA for neuronal structure. ALA, which is found in fruits and vegetables, does not really get converted very well to EPA and DHA. ALA is a cardiovascular protectant, so you get that in flax. But in order to get EPA and DHA, you have to get it from marine life, at least algae, if not anything else. And then, of course, you have the omega-6s on the other side. So you have linoleic acid, basically a pro-inflammatory agent because it is the precursor to arachidonic acid, and arachidonic acid is the precursor to all of these guys, prostaglandins, thromboxanes, and leukotrienes, all things that increase inflammation. So you have pro-inflammatory fatty acids, you have anti-inflammatory fatty acids. And so the ratio between these two becomes very important. And it's been shown that poor psychiatric health is consistently linked to low omega-3 ingestion, as in this study, both in terms of consumption and also in the blood. So those with a low omega-3 are much more likely to end up having problems. And you can see here, omega-3s, B vitamins, and cognition together all seem to improve the neuroprotection that is involved in, for instance, Alzheimer's. So if you add B vitamins to an omega-3 baseline, you can get significant reductions in brain shrinkage. So hopefully I've made the point that we can use specific components of the diet as mitigators of chronic metabolic disease. Can we actually consider them psychopharmacologic therapies? And if so, do they help systemic health and mental health at the same time? Or could they just as easily be psychopharmacologic toxins, basically poisoning those same pathways? And that's where things get a little complicated. How do you determine which food is which? And we're going to go there at the end. How do you, what are the determinants of good food versus bad food? Now, I'm not the first person to make this connection. Many doctors have postulated a relationship between metabolic and mental health. And here are 5 different books, all, on this topic. David Perlmutter, who's talked in this venue before, Felice Jacka in Australia, my colleague Bill Wilson in Lowell, Massachusetts, wrote Brain Drain, Emmer Meyer at UCLA, Mind-Gut Connection, and of course, Christopher Palmer. Okay. So this is now not just fringe. This is now like a big deal because it made Lancet. And here's a quote: "The emerging and compelling evidence for nutrition as a crucial factor in the high prevalence and incidence of mental disorders suggests that diet is as important to psychiatry as it is to cardiology, endocrinology, and gastroenterology." In other words, the brain is just another organ. And just as your liver responds to food, just as your gut responds to food, just as your heart responds to food, okay, well, so does your brain. So could we use food as a method for mitigating problems with both? Well, in order to do that, in order to have some principles, we have to know what does food do and what can you do to food to make that happen. Well, so you can add something like vitamins or omega-3s. You can subtract something like artificial colors and various allergens, particularly gluten. You can change the macronutrient composition or timing. So that could be like vegan or time-restricted eating. You could alter the microbiome, and the easiest way to do that is with fiber. It's a prebiotic, not a probiotic, works better. Or you can do all the above at the same time. That would be called the ketogenic diet. And how would this work? I mean, what is it doing to the food? The answer is it can alter CNS energy metabolism. So you get improved mitochondrial function. You can get altered CNS neurotransmission. We will talk about the glutamate to GABA cycle in a minute. We can alter the effects of CNS trophic factors. As you know, the brain is not static. There are certain areas of the brain that continue to grow and continue to generate new neurons, neurogenesis. Okay, and they are under the control of trophic factors like leptin and brain-derived neurotrophic factor, BDNF, which is a manifestation of exercise. You can alter CNS exposures, toxins, and infections. And of course, IMMH is, half devoted to this concept entirely. And you can do all the above. And again, that would be a ketogenic diet. So let's take all of these four and explore how food can affect all of those, both for metabolic and mental health. Okay, so first of all, energy metabolism. Well, as you know, every neuron needs lots and lots of ATP. It is the most energy-intensive organ in the body, and it has no place to store energy, and it has no place to store the substrate to make the energy. So it is constantly online and constantly has to be making ATP, and it does so in an enormous number of mitochondria. Well, those mitochondria have to be a tip-top shape or else. And in fact, our mitochondria are in the sewer. And the reason is, I will show you in a moment, ketones, okay, here, beta-hydroxybutyrate from the blood, enter the astrocyte and then enter the neuron and can then be burned down to acetyl-CoA. The great thing about this is, you will notice, no insulin. You don't need insulin to do that. In fact, all you need are these transporters. Now, if you're missing these transporters, you have a genetic disease and you got bigger problems than I can tell you. But ketones will basically leak across with no problem and with no inhibition straight into the neuron to be utilized. It's true in the liver here to make beta-hydroxybutyrate, and then you can use that beta-hydroxybutyrate to power the mitochondria, or you can do it in the brain as well. So that's one of the reasons why this is important. Remember, insulin is part of the problem. The goal is to get the insulin down because the insulin is actually shunting energy away from mitochondria. So you got to make your mitochondria work well in order to do this. Well, turns out there are some mitochondrial toxins in our food. This is the most severe and the most difficult one because it's in everything. It's called sugar. Now, as you know, sugar is made up of two molecules, glucose and fructose. You'll notice glucose is in green because green is good. And the reason is because glucose activates two enzymes necessary for normal mitochondrial beta oxidation. And that's why you see the green arrow going up here. It activates AMP kinase, which is the fuel gauge on the liver cell. When the liver cell and also the neuron recognizes that there's not enough energy, it increases AMP kinase, which is the fuel, which is the signal to make more and fresher mitochondria. In addition, it activates this enzyme called HADH, hydroxyacyl-CoA dehydrogenase, which is necessary to break the two carbon fragments and get them ready for beta oxidation. The sum total of which is that glucose increases mitochondrial beta oxidation, and that's good. Fructose, on the other hand, this red one, is another story. Okay, everyone says, oh, a sugar is a sugar. No, it is not. And this is the study that proves it. Fructose actually inhibits three separate enzymes involved in mitochondrial beta oxidation. Notice the downward red arrow. It inhibits AMP kinase, and I'll show you how, because we figured out how. It inhibits ACAD-L, acyl-CoA dehydrogenase long chain, which is again necessary to break up those two carbon fragments. And lastly, uric acid from fructose metabolism, a la Rick Johnson and David Perlmutter, inhibit this enzyme here called CPT1A, carnitine palmitoyl transferase 1A. This is the enzyme that regenerates carnitine, which gets the fatty acids from the outer mitochondrial membrane to the inner mitochondrial membrane so that they can be beta oxidized in the first place. The sum total of which is that fructose actually inhibits beta oxidation. Now, the food industry will tell you fructose is calories. Therefore, fructose is good because it supplies energy. No, it doesn't. It saps energy because it inhibits mitochondrial function. Ron Kahn, the CEO of Joslin, himself said the most important takeaway of the study is that high fructose in the diet is bad. It's not bad because it's more calories, but because it has effects on liver metabolism to make it worse at burning fat. As a result, adding fructose to the diet makes the liver store more fat, and this is bad for the liver and bad for whole body metabolism. Now, this is true in the liver, it's true in the brain as well. Now, we were interested in why fructose did this. And so we looked at fructose metabolites in patients with metabolic syndrome, in children with metabolic syndrome. And this is the study that we did, published in 2019. And what we did was we looked at the function of AMP kinase. AMP kinase, as you know, can be activated by a whole bunch of different things. Okay, and these are things that are all, out there in the zeitgeist as being ways of improving metabolism, such as, for instance, metformin and PPR agonists to lower diabetes, lower blood glucose, et cetera, adiponectin, et cetera. Okay, so AMP kinase turns out to be a very important enzyme. As you can see, AMP kinase is in charge of all of these good things. Here are the good things that AMP kinase does when it's active. Okay, and here are all the bad things that AMP kinase inhibits when it's active. So keeping your AMP kinase in tip-top shape is kind of important because these are the things that get you in trouble. These are the things that make your cells hum along very nicely. Well, AMP kinase has three subunits, alpha, beta, gamma, and in that gamma subunit is an active site, and there are three arginines in that active site. And arginines have an amino group that can be bound to. Okay? We found the binder. We found the thing that binds. It is called methylglyoxal. Now, we're not the only ones who found it. We're just the ones who showed that it actually has a role in obesity and metabolic syndrome. So methylglyoxal, this is what it looks like. And here's the aldehyde, reactive aldehyde. It likes to bind to amino groups. So glucose binds to amino groups with a strength of 1. Fructose binds to amino groups with a strength of 7. Methylglyoxal binds to amino groups with a strength of 250. All right. And when it does that, it in the active site, okay, it inhibits, it basically irreversibly inhibits that AMP kinase. You have basically killed it, and you have to make a new one. So basically, anything that generates methylglyoxal is going to be a problem. Well, fructose, by going through dihydroxyacetone phosphate, makes this methylglyoxal in spades. It's really hard to isolate this unless you do a liver biopsy, but you can measure the product of methylglyoxal, which if after methylglyoxal is acted on by an enzyme called glyoxylase 1, you make a product called D-lactate. So we measured D-lactate in these kids with metabolic syndrome. And what you can see is that the more obese, the more D-lactate, 52% higher. And when we took the sugar out of these kids' diets, their D-lactate levels fell by 38%. Okay? Demonstrating to us that, in fact, this pathway of fructose to methylglyoxal could be influenced by removing the substrate. So here's how it works. The fructose makes the MGO, it inhibits AMP kinase, and now you've got all of these, shall we say, metabolic effects in the liver. And here you've got inhibition of all of these others that are good. So exact opposite, because you have poisoned your AMP kinase. Now, for the same reason, metformin is protective against neurodegenerative disease, and Mir Barzilai at Albert Einstein is conducting a metformin trial to see if it will actually improve dementia and improve longevity. Okay, you can see the relative risk using metformin is on the left, which is good, saying that this is actually a rational approach. All right. Now, remember, sugar is two molecules, glucose and fructose. This fructose molecule has all sorts of bad things associated with it. And sucrose, table sugar, cane sugar, is one glucose, one fructose, O-glycosidic linkage. The enzyme in your intestine, sucrase, cleaves this in a nanosecond. So Here's sucrose, here's high fructose corn syrup, doesn't matter. Basically, they are the same. Turns out you can measure this in people's brains. So using in vivo magnetic resonance spectra, you can actually find glucose and fructose. So here's the glucose reference when you inject glucose. Here's the fructose reference when you inject fructose. Here's the reference that when you inject both at the same time. So this is what it looks like. And here's just a human being, okay, who hasn't gotten anything. And so you can see the glucose and the fructose in both. So that's, telling you this is going on in people all the time. In fact, the brain makes its own fructose from glucose through a pathway called the polyol pathway. So glucose becomes sorbitol using the enzyme aldose reductase, and then sorbitol becomes fructose. So everyone has a fructose level in their brain. Don't ask me why, because I don't really know why, but you can measure it. And if you're diabetic, you've got more of it. All right. So this is a pathway that goes no matter what. And the problem is that if you consume fructose, you're driving it even more so. Now, remember, the goal is to make your mitochondria work better. If your mitochondria are not working well, you're going to have problems with cell trafficking, you're going to have problems with neurite outgrowth, you're going to have problems with ATP production, as I just showed you, you're going to have problems with programmed cell death, apoptosis, and you're going to have problems with calcium influx. All bad things and all associated with increased psychiatric disturbances. So keeping your mitochondria up and running is job one, and fructose is a direct mitochondrial toxin. Well, turns out ketones can substitute for glucose, but they can't fix your mitochondria if the AMP kinase has been turned off. So sugar is sort of the antagonist, and ketones can't get around that. But if you take the sugar out and you put the ketones in, or you reduce the insulin so that you become ketotic, okay, you can actually fix the glucose hypometabolism, the energy deficiency, and the oxidative stress and neuroinflammation. And ketogenic diet has been shown to improve cognitive parameters in patients with Alzheimer's disease. Improves language, executive function, global cognition, memory, psychomotor speed, and attention and concentration. All, without insulin, because it's improving mitochondrial function. Now, that's pathway number one. Number four, the microbiome. Okay, the microbiome is super important in this story. So first of all, we know that the ketogenic diet alters the microbiome in very specific ways. The microbiome is basically here in the lumen of your intestine, and your intestine is a sewer. I mean, literally a sewer. It is a pipe with what in it. All right, that's the definition of a sewer. All right. Now, how come the what doesn't get into your bloodstream? All right. The goal is to keep the what out of the bloodstream. There are three barriers. There is a physical barrier, you can see here in light blue, and it's called the mucin layer. There is a biochemical barrier, which you can see here, these bars right here. These are called tight junctions. These are proteins that basically link the intestinal enterocytes together and don't allow the junk to get through in between to get to the bloodstream. And finally, you have the immunologic barrier right here. And this is primarily Th17 cells. And they make a cytokine called IL-17. So three barriers: mucin layer, tight junctions, Th17 cells. Well, it turns out sugar, fructose, affects that barrier very clearly. This is a study looking at that and showing that the stuff in the gut change with glucose versus fructose, normal chow, glucose chow, fructose chow. And that associated with fructose seemed to hold more potential to induce host metabolic disturbances compared to glucose, mainly by promoting bile acid deconjugation and taurine release. And wait for it, and compromising intestinal barrier integrity. Indeed. So fructose, turns out, it nitrates those tight junction proteins. So now those tight junctions don't work. And if those tight junctions don't work, then you get this thing called leaky gut. In addition, you'll see in a moment, fructose actually increases the growth of some of the bad bacteria. So you got increased growth of bad bacteria and defects in the barrier. And it actually affects all three barriers. So you end up with translocation of bacteria and lipopolysaccharide into the bloodstream, which then goes via the portal vein to the liver and activates the inflammatory response, the inflammasome. And that leads to fibrosis. And this is why sugar causes fatty liver disease, including cirrhosis. So this is going on in the liver. Well, it's going on in the brain too. And remember that the brain's tight junctions are the exact same tight junctions as the intestine's tight junctions. So if it's affecting the intestinal barrier, you can be very sure it's affecting the brain barrier too, because they're the same protein, the zonulins. In addition, sugar alters that Th17 component. So here on a regular diet, you can see the Th17 cells making IL-17, and you can see a very clear barrier here. The intestinal enterocytes are not letting the junk in, all right? On a high-fat diet, on a ketogenic diet, you see the Th17 cells still there. You see the IL-17 still there. Yes, some fat will leak through, and so you will increase your fat absorption, but it's still keeping the junk out, because the intestinal barrier is still functional. But now go on a Western diet that is high sugar and high fat. And now the barrier basically is destroyed. You don't have Th17 cells, you have Th1 cells instead. And in fact, the barrier is broached here. And so you get leakage of everything across, including bacteria, including cytokines, including, of course, stuff like more fat. In addition, that Th17 cell is very responsive to high glucose levels in the blood. So high glucose, increasing reactive oxygen species, activating TGF-beta. TGF-beta is basically the chain reaction for the immune system. TGF-beta is what turns a senescent immune cell into an active immune cell that goes and kills stuff. All right, TGF-beta you want to keep down to keep inflammation down. Well, high sugar is going to activate those Th17 cells, and now you're going to get inflammation. And you can see the pathway between the microbiome, okay, here, tissue damage and microbiota dysbiosis here, via the Th17 cell and IL-17, leading to numerous immunologic and inflammatory conditions throughout the body, including multiple sclerosis and including potentially psychiatric conditions. And I'll show you that in a moment. So we know that in humans, the more sugar you consume, the worse your autoimmune disease. And the reason is because of leaky gut. So this was shown, sorry, let me go back. This was shown that higher consumption of free sugars in patients with lupus erythematosus led to a much higher increase in symptoms, okay, and disease activity, right, and the complications of lupus. Now, this one I love. I love this because it's so easy to see. What we're doing here is we're growing streptococcus, okay, group A strep. We know that group A strep is responsible for numerous psychiatric diseases. Of course, we've known that since 1791 when Sydenham described the chorea that bears his name associated with rheumatoid arthritis. It turns out rheumatoid arthritis is made much worse by group A strep. It's also responsible for PANDAS, OCD, tic disorders, etc. Well, take group A strep and grow it on glucose, not much. Grow it on sucrose, and look how it takes off. Grow it on fructose, and look how it takes off. Grow it on sucrose and glucose. Look how it takes off. In fact, glucose is not a very good substrate for group A strep. Fructose is the preferred substrate, and we know that because the thing that makes cavities is group A strep in your mouth called strep mutans, and it loves fructose. Okay, so fructose is a preferred substrate for the bacteria that causes all of these psychiatric diseases. So how smart is it to be consuming sugar when you have those? So here's what we've been doing. This is the, you can see ever rightward march for the last 200 years. And on the y-axis is our consumption of sugar. So here's the growth of the sugar industry in the late 1800s. And then we reached stabilization in the early 1900s when price equaled demand. Here is the rationing of World War II, comes back up to the same level. And here's the advent of ultra-processed food in the mid-1960s. Okay, and then of course, the substitution of high fructose corn syrup and also the dietary guidelines, which said sugar for fat. Next, I'm going to overlay on this graph the percent of GDP in America spent on healthcare for the same period of time. What do you see? As soon as processed food entered our world, that's when our healthcare costs started to go through the roof. And the reason is for the four things I just showed you. So what can we do about it? All right, we got to fix the food. That's what we can do. We have conducted a full analysis, my colleagues on our scientific advisory team, Tim Harlan, Rachel Gao, Wolfram Alderson, Andreas Kornstadt, and I did a full analysis, and we've come to the conclusion that there are three things you have to do in order to make food healthy and to reduce the risk of both metabolic and psychiatric disease. Feed the gut, protect the liver, support the brain. Those three. Protect the liver, hydration, environmental toxins, reduce glycemic load, get rid of the sugar, okay, for all the reasons I've just shown you. Feed the gut, soluble and insoluble fiber. You have to reduce processed carbohydrate. You need whole intact food matrix. It's called real food. Okay, prebiotics, that's dietary fiber. Probiotics when needed, to replace the gut microbiota, and get rid of the sugar because it's making the wrong bacteria grow. And finally, support the brain. Nutrient-dense foods, healthy brain essential fats like omega-3s, less omega-6s, healthy proteins, lots of tryptophan, okay, and B vitamins to help clear homocysteine, which is pro-inflammatory, and of course, get rid of the sugar. So, last slide. Thank you for sticking it out with me. Okay, food is not medicine. Food can be medicine, but food can also be poison. Okay, just because the food industry calls it food doesn't make it food. That's the key, right? Cheetos is not food, right? And if you think it is, we will never solve this, and our psych issues will just continue to get worse and worse and worse. So food has effects on both body and brain. Metabolic health and mental health have the same substrates and mechanisms. Food can act as an initiating or aggravating factor for many metabolic and psychiatric diseases. Food can affect the brain through mitochondrial dysfunction, glutamate neurotoxicity, insulin resistance, and microbiome dysfunction and leaky gut. The ketogenic diet or sugar restriction may help these pathologies, but randomized controlled trials have yet to be performed. Those have to be done. And I implore any of you who do clinical research to look into whether or not you can do those studies, and I will help you in order to get those studies done. So with that, I will stop my share and take any questions with whatever time we have left.
Thank you so much, Robert. That was incredible. And I know everybody's absolutely loved it. We have very little time, but there are a couple of questions that I would like to try to cover, which are similar. So the first one is, taking the 30,000-foot view, are you advocating to reduce whole fruit intake, hence decreasing fructose, or more specifically, high fructose corn syrup, sucrose, and ultra-processed food intake?
Right.
If you are recommending reduced fruit, how much is okay? Okay,
so fruit has fiber. Fiber is the antidote. Fiber reduces the rate of glucose and fructose absorption from the intestine so that it doesn't hit the liver. Basically, fiber makes the fructose and the glucose the food for the microbiome. So fruit is good. Fruit juice is bad. Okay, as soon as you juice the fruit, you've destroyed the fiber. And so I am not advocating a reduction in fruit. Now, if you want to be on a ketogenic diet, you can't eat fruit. That's true, because you will generate an insulin response, and as soon as you generate an insulin response, no more ketones. So if the goal is a ketogenic diet, then fruit has to come off the menu. But I am not, if you're just trying to get rid of the added sugar, fruit is not added sugar, because the fruit comes with the antidote. It comes with the fiber. We're talking about the sugar that's obvious. We're talking about the sugar in the candy, the cakes, the ice cream, the soft drinks. Okay, but we're also talking about the sugar in the yogurt. We're talking about the sugar in the breakfast cereal. We're talking about the sugar in all the places that the food industry put it to make you buy more, because sugar's addictive.
So one more very cheeky question, because I know we're totally out of time. What about the alcohol sugars that are used in so-called keto bars, such as monk fruit, etc.?
Right. So the erythritol, the xylitol, the maltitol, the sorbitol, okay, they are sugar alcohols. They don't get absorbed, and they don't taste very good, to be honest with you, but they are osmolytes. They hold on to water. So if you have to use a sugar alcohol to sort of get sweetness up, you have to use enough that will basically lead to significant GI distress, whether it's bloating, whether it's diarrhea, whether it's it just changes in bowel habits, and you don't feel very good after them. If you must find a sugar extender or sugar substitute, the one that I think has the most data for being metabolically healthy with the least side effects is one called allulose. And allulose right now is 12 times the price of sugar. However, just last week, UC Davis patented and published on a new method for allulose production that is going to reduce the cost significantly. And that, I think, will be the way to go. What we've learned is you need a teaspoon of sugar per serving to get the reward signal, because after all, if you don't get the reward signal, why would you ever go back and eat it again? So we have created for this food company in Kuwait a line of foods with 1 teaspoon of sugar, using allulose as a sugar extender to extend the sweetness. And it's selling like hotcakes, except it's not hotcakes, it's ice cream.
Well, that's wonderful, because that answered another question. So that's brilliant. And just, unfortunately, we're out of time, but that was brilliant. I will just read a comment. Best lecture so far. He makes it so easy to understand. And I've heard that many times. So Robert, thank you so, so much. You are amazing. And we all agree.
All right, Kiki.
Thank you so much for listening to the Mind Health 360 show. I hope that we've helped you realize that mental health symptoms have root causes that can and need to be addressed in order to sustainably heal, and have given you some ideas about steps you, your loved ones, or clients may take to start their healing journey. Please share this interview with anyone you think may find it helpful, and don't forget to subscribe to keep up to date with our latest interviews on integrative mental health. If you want further information, please go to www.mindhealth360.com or find us on social media. This information is for educational purposes only and is not intended to diagnose or treat any disease or to replace medical advice. Please always consult your healthcare practitioner before discontinuing any medication or implementing any changes in your diet, lifestyle, or supplement program.